All right, folks, we are to get into 5-4 from Algebra 2, the Algebra 2 text, that is. All right. And this is 5-4. We're going to start today with radical expressions. And complex numbers. All right, so we've already done a little bit of this at the beginning of the year, but we have to go back to this because it's going to become really important to us later on. So what we're going to do, I'm just going to jump right into some examples, some things that, again, I know you've seen before, but we're going to just give you one more chance at it and take a look at it. So some basic things. If we're asked to simplify, remember that was the goal in the majority of the problems. We're going to do a little bit of solving today, but mostly simplifying. All right, so if you're asked to simplify something like, let's say, let's do that one. For first example, the square root of 168. Now, I know for many, this can be a problem because with larger numbers, it's kind of hard to see square roots in there. So what I suggest you do, if you remember, is you can do something like a prime factorization where we make a factor tree. I know 2 goes into that. 2 is a prime, the smallest prime. So if I say 2 goes into that, I know it goes in 84 times. I look at this number, and again, I know 2 goes into that. So I just keep taking that out as many times as I can, and I get down to 2 and 21. So far we have 2 times 2 times 2 times 21. 21 I know is 3 times 7. So if we were thinking this in prime factors, it would be 2 times 2 times 2 times 3 times 7. Now, the way we use with a square root, if it's a square root, we would look for pairs of factors. This is one pair. I don't have any other pairs. There's only 1, 2, 1, 3, and 1, 7 left. So this is the way I'm going to think of it. I'm going to have 4 times 2 times 3 is 6 times 7 is 42. So this is going to be 4 times 42. So I'm thinking of it this way, the square root of 4 times 42. Now remember, we have the rule that says if we have the square root of AB, that is equal to the square root of A times the square root of B. So I can take the square root of each of these individually. Square root of 4 would be 2, and 42, again, we know has no other nice paired or square factors. So we're just going to leave that underneath, and we get our simplified radical. This is simplified radical form. Again, you're going to want to know if we ask for simplified radical solutions, that's what we're looking for, all right, is that. So now, let's do another one. Another example, simplify, same directions. Let's do the square root of negative 60. All right, another example. We'll call it example 2. Square root of negative 60. All right, we've got something different here. We have to look at, again, some of our rules. We know that the square root of negative 1 is equal to I, right? So in other words, we know that I squared is going to be equal to negative 1. And if you remember, we went on to say I cubed is going to be equal to negative I, right? Because it's negative 1 times the square root of negative 1. And then I to the 4th is going to be equal to positive 1. And then it starts to repeat, right? So that's the system we have for that. Now, again, just a quick reminder of that. So what I'm going to do here is, first off, I know I'm going to think of this as the square root of negative 1. And now, again, I have to break down 60. And I'm going to do this pretty much every time. I do this. I go 2 and 30. I know that is 2 and 15. and 3 and 5. So I have my common or my prime factors here. That multiplies to 60. I have one pair of them, so I'm going to think of this as 4 times 15. So now looking at this, the square root of -1, again, using that same idea, I can take the square root of each one of these. Square root of -1 is I, square root of 4 is 2, square root of 15, nothing I can do with that. So putting this in the order that is most common, well, I did not want to write there. Letters, then roots. And we'd get 2I root 15 for that one. All right, so now we have to look at the next step. Into having some variables involved. So let's look at another one. Again, same rules. We're doing simplify. And so let's look at example 3. Let's do this one. Square root of 180 x to the 5th y squared z. All right. So again, let's break this down. When I look at this, and again, I probably wouldn't write this out every time, but I'm going to start to break down each piece of this. 180, I'm thinking of 2 times 90, 2 times 45, let's see, 3 times 15, and 3 times 5. So I've got a pair of factors here, a pair of factors here, and one left over. So I'm going to break it down that way. I'm going to think of this as the square root of 4 times 9 times 5. All right, so that's how I have it so far. Square root of 4 times 9 times 5. Now, this x to the 5th, I'm taking the square root, so I want pairs of those too. What I'm thinking is, I know what the square root of x squared is, right? Square root of x squared, well, this is technically absolute value of x. Remember that? If we take even root, even power, and it comes out odd, we have to put an absolute value on it. That's that even, odd idea. But in this case, we have an even root of an odd power if I look at x to the 5th, right? But I know I can take the x squareds, and I can even take, if anything that I can divide it into, I can use this. So what I'm going to do, I don't know if that made sense to you, I'm going to do this. I'm going to think of this as x to the 4th. I think of how many times I can get 2 into this. 2 goes into 4, so I'm going to take it into 4, because I can take the square root of x to the 4th as x squared. And that leaves me 1x left over. All right? And then the same thing, y squared is okay as it sits. And then z also is good as it sits. Let's separate that stuff. So now we can take piece by piece. Again, I try not to do too much at once, guys. If you try doing all this in your head, it's where you start making mistakes. If you break it down into just this little bit of a step-by-step approach, you're going to find you make a lot fewer mistakes. All right, so what do we have here? We've got 2. Square root of 9 is 3. Square root of 5 is just square root of 5. Can't do anything with it. Square root of x to the 4th is x squared. That was even, came out even. It's not an even, odd, right? So I don't have to worry about an absolute value. Then I've got square root of x. Nothing I can do with that. Then I've got square root of y squared. Well, now it's even, and this comes out odd, so I have an absolute value of y. And nothing I can do with the z. So now I've got all these individual pieces. Let's take numbers first. 2 times 3 is 6. I've got those used. Now, again, I'm looking at things not under radicals first. I've got an x squared, absolute value of y. Go alphabetically, x squared, absolute value of y. I've used those. Oops, I used those, sorry. All right. Now, what do I got left? Everything that's under the radicals got to go there now. I've got an x, a 5, an x, and a z for under the radical. And we've got our simplified version of this. All right. So, one more example of this simplifying, and then we'll move on to a solve. All right. I think this is example 4 at this point. Again, simplify is the directions. And let's look at this one. Let's do the square root of negative 8 x to the 8th y cubed z to the 7th. All right, so now, again, I'm going to break this down piece by piece. I know I've got square root of negative 1 times, this is 4 times 2, times x to the 8th is divisible by 2, so I'm going to leave that. This one, the y's I'm going to break into y squared and y. Those two together make a y cubed, and it gives me one even one. Z to the 7th, I'm going to call z to the 6th times z. Because again, I want to be able to take square root of as many as I can. And now I do piece by piece again. Square root of negative 1 is I. Square root of 4 is 2. Square root of 2 is just that. Square root of x to the 8th. Square root of x to the 8th, 2 goes into 8 4 times, so that's x to the 4th. Again, we did even, 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 so it's not one I need absolute value. Square root of y squared, that's y, and that was even, even, odd, because it came out to the first power, so I need an absolute value. Then I get square root of y left over, that's that one. Square root of z to the 6th. Z to the 6th, when I take the square root of that, I divide it by 2, so it's z cubed. Again, even root, because it's a second. Odd, that has to go in absolute value. And then I'm left with a square root of z. So, what do I have here? Let's start collecting. I'm collecting numbers first. I see a 2 here, that's it. So I got a 2. I tend to put my like x, y's, and z's, that kind of thing, before I do any i's. So I've got rid of the 2. I'm going to go to x next. I've got an x to the 4th. So I put x to the 4th. I've got an absolute value of y and an absolute value of z cubed. So I'm going to do absolute value of y z cubed. I can put those both together. In fact, I should put both those together. And so I've taken care of those. Now, the only thing left that's outside of a radical is an I. So I put I here, and then square root. You will see in the book, they'll put the I on the other side of the square root. I don't like that, because when you have, say, the square root of x and then an I, it's hard to tell if that's under or not. So I don't like that. Put it in front of the radical. It makes it easier for me to see that you know it's not under there. All right, and so we've got the I taken care of. Now what's left underneath? A 2, a y, and a z. If you have any trouble with these whatsoever, I strongly suggest you approach it this way, guys, where you break it down piece by piece by piece, and don't overthink it. Just go through the process, so to speak. Trust the process, like I say, and you'll hear me say so many times this year. And that's how we do simplifying. Again, something we've done already this year, but just revisiting it, just trying to take it and bring it back into your head, because we are going to be using it as we move forward. And this chapter, we're going to use it quite a bit. All right, so now where are we going? Well, let's do some solving. So, solve, and they give you something like this. These are just going to be real basics to start. We get something like this. All right, x squared plus 11 equals 0. How do we solve this? Well, what do we always do? When we're solving for x here, right? So solving for x, we got to get it by itself. First thing we got to do, get rid of the 11. That gives me x squared equals a negative 11. Now I've got x squared, I got to get to x. So I take the square root of both sides. So on this side, square root of x squared is x. Now I know we just got done saying that was absolute value x, but we're going to deal with that on the other side, because what it's going to tell us here, the square root of negative 11, that's the square root of negative 1 times 11. So that's going to be, first off, when we're taking the square root, we're going to call it, when we impose a square root on a function, what I mean by that is this equation started out without any square roots, right? The previous examples, we had square roots already there. This one, we are using as a solving step, the square root function, right? In order to get x squared to x, we had to take the square root, and that meant the square root of both sides. If we do that, and this is the only time you have to worry about this, if we take a square root, if we impose it on the function as a solving step, we have to always consider plus or minus. So remember that. If you're solving an equation and you take a square root of both sides, you have to remember it's plus or minus. All right, that's going to accommodate that whole thing. So now what's underneath here? Well, I've got an I because I've got a -1, and square root of 11, nothing I can do with it. So this is our solution. X equals plus or minus, or our solutions, I should say. There's two of them there. X equals positive I root 11 and negative I root 11, which we can write as plus or minus I root 11. All right, so let's do another one. Let's do, I'm just going to do it side by side so you can see similar idea. 4x squared, we'll do plus 16 equals 0. So first thing we always do, if they don't give it to you this way, I think in this unit they will. It'll be our next one. We're going to have a little more complex problems. But with this one, we want to make sure we're set equal to 0 when we have a quadratic when we start to solve. So now starting here, we need to get x by itself, so subtract 16. When we subtract 16, I get 4x squared equals, negative 16. Now I still don't have x by itself. I've got a scalar multiple. I've got to divide that out. So I divide that out and I get x squared equals -4. Again, I'm going to take a square root to solve this, so I need to consider plus or minus when I do it. I'm going to take a square root of this side, square root of this side. When I do that, I end up with on this side x, on this side plus or minus, as we just mentioned. Now, square root of -1, I'm thinking of this thing here. Let's just do this to the side. If I have this, I'm thinking of this as the square root of -1 times 4. So the square root of -1 is I, square root of 4 is 2. So I would write this as 2I, and that's plus or minus 2I, two solutions there. And that's it, guys. That's what we're doing for today's work, where you're going to be working on problems that involve simplifying radical expressions, and then you're going to have some basic equations to solve. There is one other type of equation I want to show you, just because it comes up every year, and it's kind of an extension of these. But I want you to understand what it means when we have a complex number. Complex numbers come in a certain form, and that form is what we generally consider a plus or minus bi. In other words, we have this is a constant, meaning it's just a number, and another constant. Well, I should have just done this. Let's make that arrow go from here. These are both constants, all right, a and b. So what does that mean? You could have something like 3 plus 2i. You could have -5 minus 6i, -4 minus 3i. Anything in that form is a complex number, where it has a real component, right? This side, here, let me do this. This side of it, the a values, these are real numbers. And then the other side, this side over here, we have our imaginary numbers. All right, when we have real and imaginary combined into a single number, we call that a complex number. It's part of the complex number system. All right, so when we have this, they could give you problems, and I want to give you an example of this just before we go, because I don't want you to get confused. They're not that bad when you see how you do them. All right, so what they're going to ask you to do is something like this. Let's say 4 minus 6i is equal to 8m plus, let's say 3 how are they going to write it? 3ni. There we go. So if they ask you to find the value of m and n, then that's what the directions are going to be. Find the value of m and n. So what I want you to realize here is we have a real number, and then we have a complex number. So in order for these two, I should say an imaginary number, I'm sorry. In order for these two complex numbers to be equivalent, these two things have to be the same. So in other words, 4 has to equal 8m. So what does that mean? That means m equals 1/2, right? I'm going to divide both sides by 8 to solve for m. M equals 1/2. We got part of it. In the same way, this -6i has to equal 3ni. So what do I do here? If I want to solve for n, what do I know? -6 has to equal 3n. Divide both sides by 3, and I would get -2 equals n. We've got our m and n solved for. All right, again, just using equivalency with complex numbers. And now that truly does it. We are done with 5.4a. I should have said that at the beginning. This is the first part of 5.4. We are going to do more tomorrow. So you need to be ready for that. All right, have a great day, and I will see you in class. Bye, guys.